welcome back to the channel. Today we're doing orthographic camera following and just showing you how to set this scene up. And then we'll take it a little bit further because what I want is sort of like an XCOM style where if I click somewhere, this is going to walk along over to the point that I click on. So we're going to do that today. If you don't know what an orthographic camera is, it's like you've got perspective and then you've got orthographic. So orthographic, doesn't matter how far away it is from the camera, it's going to look the same size as if it's close, right? And that kind of looks like this. So you'll see this in a lot of like isometric looking games just to keep everything looking good, right? A lot of the times this is done just with 2D because obviously, you know, 2D doesn't have perspective. But if we're trying to fake that in 3D, this is how we're going to need to do it. So you're going to need to create a new project in Godot and then create a new 3D scene, call it main scene, and then save it into a folder, scenes, new folder. And then what do we do next? We're going to need to create a camera. And then just before we mess around with it too far, the way that you switch it over to orthographic is over here. So you'll see the projection is either perspective, orthographic, and frustum. I don't know what the hell frustum is, don't ask me about that. But orthographic, you see, there's no tapering or like a wedge shape to it because there's no perspective, right? Everything that you see is going to be projected onto a flat plane or something like that. I don't know, I'm not a scientist, I don't know how it works. So I'm gonna show you what that looks like in practice by just creating a CSG box, and then we're going to look at it in both perspective, which you can see over here. I'm going to go like this, Control M to move the camera to that position. I'm going to hit T so we can move it along that axis. And now when we look at this box, okay, we're just going to hit F5 and then go select current, so it loads this up. When we look at that box, not that you can see much, I'm just going to go here, add the sun and the environment just so we've got something to work off. I'm going to hit F5 and then we can see you've got perspective, it's normal, right? And then if we switch that over to projection, the projection over to orthographic, you can see there's a little bit of warping, right? So as well, what I'm going to do is just make it so this doesn't, screw around. And also I want it to start full screen. And I want it to be 1920 by 1080 for when I do have it windowed. So we're just going to do that. Cool. So then if I split this view into two different viewports, we can actually preview the camera here. And then we can see the live update from switching it between perspective and orthogonal, orthographic, whatever you want to call it, right? So then you see if I move the camera away, it's not actually going to make the object smaller like it would with perspective. So obviously it's a very specific effect that you can go for in your games, right? It's really hard to achieve any other way, right? To get the same effect, you'd need to have your perspective camera like a very, very long distance away and then just like zoomed in. But yeah, just don't do that. Just do this, all right? So we can also see if I move this around and I create another one and I push it back a whole bunch of distance, it's going to be the same size regardless of how far away it is, right? Because it's orthographic. Cool. So I'm just going to delete both of those for right now and we're just going to start again. So what we need to do first is I'm going to grab these two, I'm going to reparent them to a new node, and I'm going to call this environment. I'm not sure how loud my volume is, by the way, so hopefully it's not super duper loud. And then I'm going to go CSG box. And then I'm going to go down 0.5 meter by holding Control and Shift. And I'm just going to make a big wide open space here. And then I'm going to import a texture just so we're not looking at white. I'm just going to drop this grid white texture onto it. And then we're going to set that up to be, what's it called? So you go in here. And then you look at the UV1, triplanar, that's the one. There we go, make it world triplanar, just so things will line up, right? Just so we've got something to look at, right? Then I'm going to create that camera again. I'm not really going to do anything with it except switch it over to orthogonal because I want to kind of have it on a very specific angle. So I'm just going to move that up and then I'm going to create a new node 3D. called world geom, and then we're going to move the CSG box inside of that. We're going to create another CSG box. In fact, we could even just duplicate this one so we can keep the texture exactly the same. Cool. Just so we've got something to sort of cut up the terrain. The terrain? Yeah. Alright, and we're just going to go check to see how tall this is, because we want this to be sort of the same size as a building. Yeah, okay, so we're only a meter. So 3 meters tall. I'm going to make it about that big, and then I'm going to create a couple copies of them. I don't know why we're using this little view here. There we go. We'll just do that for now. Okay, so where I want to move this is actually quite specific. So I'm going to rotate it down 45 degrees. I'm going to hit T to make sure we're in global. I'm going to move it up a little bit, and then I'm going to move it over. Now, we need to sort of see what this looks like. Now this size we actually need to increase, because we need to set the size to something. We'll just go 10 meters for now, right? And then I'm going to rotate it on its other axis, so on the Y axis, and I'm going to do it 45 degrees. And now you'll see we're actually at an isometric angle, but I don't really want that, right? So what I'm going to do for a little bit more stylization is I'm going to angle it about, what's that, like 30 degrees, maybe 15 degrees, 30 degrees. There we go. Just so it's like, it's not super 45 degrees, right? Because I don't really want it to be like that. In fact, I might even go a little bit less. Like I kind of want like 25, yeah, like 20, 25, something like that, right? And then if we load that up and have a look, we can see, yeah, we've got a pretty neat angle. So next thing we're going to do is add a player, and we're going to get the player to move around. So we're going to go character body 3D and call this player. And then we're going to save branch as scene, call it player. And we're going to go into that scene. We're going to add a collision shape, 3D. Going to make it a capsule shape. Or what was that? Disabled? No, don't make sure that's not on. 0.25, 1.8 for the height. And then we need to move this up by 0.9. And then we're also going to create a mesh instance 3D. We're going to do the exact same thing. So we're going to create a capsule. It's going to be 0.25, 1.8, and then we're going to maybe make that 8, just so it doesn't look so smooth. Maybe make it even a little bit less. We kind of want to see the shadows a bit, or I do. I don't know. You guys, we'll make that 3. Yeah, something like that. Like 6 there. 7. Don't like hexagons. There we go. Looks good. Alright, so we're going to set the collision, layer to 2 as well. It's a good time now to actually name these. So world and player are the only 2 that we've got at the moment. The world doesn't actually have collision yet, so we're going to need to add that, right? So we're going to choose these CSG boxes. I'm not sure if you can do them all at once, and just go enable collisions. So it's going to be on 1 by default, which is fine. And now we're going to go find our player. We're going to put him on the screen somewhere. Perfect. Now we're going to go into the player script. Well, into the player, scene. We're going to create a script, and then we're going to go to the template and make sure the basic movement template is on. And then once we do that, we've got a base template to work off of for our character. So here we go. Why is it not working? It might be because there he is. Okay, it was working, but we're like off screen somewhere, right? Cool. So I don't know why it was doing that. That's strange. Anyway, we're over here. We look good. We're bashing into the walls like a player should. I'm using the arrow keys, by the way. And then the next thing we've got to do is we've actually got to make that camera follow the person, right? So up is this direction. If you want it in the other direction, so instead of going up to the left, you want it to go up to the right, just rotate the camera a different direction. But what I suggest is, yeah, not doing that, right? Like, and that's why I'm going to turn this into a point and click movement thing, right? Okay, so in world geom, we need to actually change this type from a node 3D, I know I lied to you before, to navigation region 3D, and then it's going to bitch at you, so you've got to create a navigation mesh, right? And then we're going to actually need to bake that navigation mesh. Cool, so we can see where that baking is. It's a little bit dodgy, I'm not sure if you can see this. There's a massive hole right here, and that's just like some sort of, you get these glitches sometimes, I don't know, you've just kind of just got to rework the world, the navigation mesh. Make sure it's not getting simplified or anything like that. So here, maybe I just changed the border size to 0.1. Hole's still there, not sure. Maybe we make it 1 meter. Yep, and then the holes kind of disappeared. It's really hard to see, but these are the sort of like little issues you get, like even here. So we're gonna work on this a little bit, right? But for right now, we're not gonna bother. We've got our navigation mesh. It's not inside these boxes. It's actually, well, there is, but you don't worry about it. It's because there actually is a flat plane there. And so if you were to get inside that box, you could still move around in it. There's a bit of navigation on top of the box. As you can see, there's a little bit of buffer zone around the box where we're not going to be able to get to. So now that we've got our navigation mesh in, like I said before, we're going to make the camera actually follow the player. So we're going to take this camera and we're actually going to stick it into the player scene. Right here, yep. Camera 3D. Cool, so then we're going to have a look at what that looks like. Because I'm not sure if we can even see the player at the moment. There we go, there's the player. Alright, cool. So we're going to reset all of this. And I'm going to drag this out quite a bit. Maybe like, 30 meters. Going to lift it up. Maybe 10. We're going to angle it down. What's that, 45? No, that's not 45, it's like 15 degrees. We need to make sure it's angled down like 45 degrees. And then, yep, we're going to move this up. So what's this at? 20 something now, 22. Cool, and then we're going to go do the rotation stuff. So this is what I mean. If you want it in the other angle, on the other angle going up, you've got to rotate it in the negative on the Y instead. So what did I want? I wanted about 25. So we're going to move that over here, and I'm sure there's like a way better way to do this, but this is just the way that I'm doing for now because it's quick. So now that we've got him around the center of the screen, I kind of want him to be a little bit lower just because he's going to have a little bit of height on him. And so if we were just pointed directly at that origin point, I'm not going to get that same effect. So then if I go start this up, make sure that it looks the same, yep. And now obviously we don't want some weird dodgy camera like this. We kind of want it to be a little bit smooth. So what we can do is we can actually replace this camera 3D. So we're going to duplicate. We're going to replace this camera 3D. Change the type to a marker 3D. Going to change its name to camera marker. And then this camera 3D, we're just going to, yep, camera 3D. So on player, we're actually going to still have the camera childed, or have the player as the parent, but we're going to go to transform and we're going to make it top level. Now what this does, if you've never done this before, is it stops it from following. It just completely stops it from following, sends it back to 0, 0, right? So what we've got to do every frame, or every physics frame, or no, every frame, is we've got to move, because it's a camera, you've got to do it every frame. We've got to move our camera 3D to the camera marker position. So, bunk. In fact, we might actually have to do this on physics process, but we'll do it in process for now. So we're going to get a reference to the camera. We're going to get a reference to the camera marker. And then we're going to go camera 3D dot global position. Not position, because we're working with global positions now that it is top level. It's no longer parented to the player anymore. It is, but not as position, not as transformation. Camera marker dot global position. So the global position of the camera, every frame will move to the camera marker's position, which is where we had the camera before. Cool, so that's working. I'm going to just actually update this floor a little bit so it looks different. It's probably going to be easier than changing the other stuff. So I'm going to go make unique. Change this to green, like even a gray, something like that, just so it looks different. Cool. And now if we run that, yeah, we can see the difference between these buildings. And obviously you're going to need to do a lot of shadow work for this to actually sell the effect, right? But what we can do, now that we've separated our camera from our camera marker, is we can actually lerp the position here. So on ready, we actually want that to happen immediately. So we're going to go to func ready. Bam. So as soon as the game starts, it's going to move it into position, and then we're going to start moving it slowly. Because what you'll see if we don't do that is it's going to start at 0, 0 and then whoosh, snap over to the player, like kind of nicely, but like you don't want that to happen when the game starts up. It's kind of weird. So we're going to make sure that we have the right thing here, which we do. So we're lerping between the current position of the camera and where it's supposed to be, right? So we're lerping the camera's global position from where it is to where it should be. And then we can set the speed. So if we set it to delta, you're going to see this is actually quite slow. But you can see the effect is there, right? And this is why we also do it on the process frame, is because we need it to be smooth. If we were to do this on the physics process, I don't think you're going to get that amount of smoothness, right? Maybe with physics interpolation, because the other thing we should probably do is make it so this is interpolated. So this mesh instance here, we'll make sure the whole player. Yeah, we're going to go physics interpolation on. Going to go to the project settings. In physics, common, we're going to turn interpolation on, and we're going to turn the physics jitter down. And now if we run it, the player should be moving around a little bit smoother. But see, we're getting the jittering, and this is what I mean by, like, we might actually have to do this here. So we move the character, and then we move the camera, right? So by doing that, you can see everything's super duper smooth. It's a little bit confusing when you get into physics interpolation, because it basically implies that like the engine is going to do the smoothing itself. So you don't need to really do any of the manual stuff on physics. I mean, on the process frame, but every game requires a little bit of experimentation, especially if you're strafing and moving your mouse at the same time with a perspective camera in 3D, first person. Yeah, it gets a bit confusing. So I'm going to go delta times 5 just to snap it a little bit faster. I'm not really too happy with that. Maybe we go 2.5. Cool. And obviously if you just set it to like infinity, it's going to be, you know, it's going to be there. Or you just like, I don't know, infinity, I guess it'd probably jitter. But yeah, like just don't lerp it. You know, if you want it to be snapped, don't even lerp it. Right, so now that we've got this, it means that we can move forward to, first of all, fixing up these shadows, which is as easy as going to our directional light. We make sure that we've got our, so we can't really do that there. I'm going to copy the camera out of this scene. I'm going to plop it here. We're going to call this scene camera. I'm going to make sure that this isn't set to current. Then we're going to go to player, make sure this is set to current. So then we do that because now we've got two cameras. So we need to discern between them. The engine needs to know not to load both of them up. I'm also going to just scatter around a couple more of these. Give ourselves a little bit more to play with, and then every time you update the geometry, you need to bake the navigation mesh again. Cool. So in the main scene, we're going to view this camera here. We're going to view it there. Awesome. So we've got a little bit of a good idea of what it looks like now. So again, we're going to hit T to switch between them, make sure that we're in global. I'm going to move it over to an area where I can see the player's shadow and also a little bit of an extra shadow there. So go over to the directional light, and then what we can do is with the directional shadow, we set this down really, really low. So what I do is 0.01. Oh, 0.1? Do I do 0.1? No, 0.01, 0.02, 0.03. So I've found that this kind of works. I'm not sure why. It's something to do with the orthogonal view, but you're going to need to play around with that a little bit, obviously, depending on the art style of your game, right? Cool. So now that that's done, like I said, we can move on to the mouse clicking navigation. So we're going to do that in player. Go back to the script, and all of the magic is going to happen inside here, right? So I guess the first thing we have to do is set up a input map. So move to click, or we just go the move click. We might use this, we might not. So mouse right button. Yeah, we'll make mouse right do that, and then we'll go interact. Will be left mouse button. So interact, click. So click move and click interact. Yeah, we'll do that. Click move, click interact. Just so we don't get it mixed up. We're probably not even going to use the click interact, but just so we don't get mixed up here. Cool, make sure that that worked. Yeah, perfect. And now what we have to do is we have to wait, or we've got to monitor for the click, right? So if we go func input, and then we go if event is mouse button, then we can go if input dot action is action just pressed, click move, then we can do stuff here, right? So we're going to create a new function called move to click. So this is also going to handle whether we actually move or not, right? Perfect. So we're going to cut that there. Func move to click and pass. I'm also going to zoom this in a little bit. Expression is of type input event, so it can't be mouse button. What? Oh, it's input event mouse, no? Yes, right, because it's like key press, no. Wait. No. Yeah, input event joypad button, input event mouse, input event action. Yeah, okay, yeah. So input event mouse button, sorry. So the move to click, we're just going to print hello there. And then when we click in game, come on, no! All right, I'm left clicking. What am I doing? Right click. Perfect. So what do we have to do? We basically got to remove the manual control, although we keep that in there for now. And then we have to create an agent, a NavigationAgent3d here, right? And then we're going to need to get a reference to it, because this is actually going to control the player's position. So once we have these few things in here, we could probably just move on to figuring out where we're actually clicking, right? So we have to do a little bit of translation here of position from 2D to 3D. Yeah. Okay, basically you want to pinch this piece of code just like I did. Thank you to whoever this guy is. Yeah, I basically just stole this, right? So what this is going to do is it's going to return your mouse position, right? But before you run ahead, it doesn't work, okay? So I'm going to show you what I mean by it. We're going to create a quick little mesh. We're going to make it a little box. So 0.5, 0.5, 0.5. And what we're going to do is we're going to use this box to actually show us where we're clicking. So I'm going to make it top level as well, just like our camera, by going into transform top level. I'm going to grab a reference to it here. The click box dot global position equals cursor pos. Now if we run that, I'm going to see, we right click, we don't see anything. And then, whoa, what's this? We can actually see something, but it's completely off. Like I'm clicking over here on the top right, right? what I found is as you increase this number, the accuracy increases. So I'm talking about this number right here. We've actually increased the accuracy quite a lot. I don't know why that's the case, but that's the case. All right, so keep that in mind. I'm just going to go delete that click box because we don't need it anymore. And then what we're going to need to do is take that position and then slam it into the navigation agent, and then we're going to need to make the navigation agent move for us, right? So we go NavigationAgent3d target position equals cursor pos, right? Cool. And now that we have that navigation thingy in there, we can go to the navigation agent and actually turn on debugging mode, right? And then, so that what that's going to do is show us the path that it's trying to take, right? And then before we get to the move and slide in the physics process, we actually want to create a little bit of space. And there's a cleaner way to do this, but this is the easiest way to do it, right? So if you just want to pause the video and then copy that out, you'll pretty much get all the code you need to start moving around from a mouse click. So we're going to right click as we move around. Yep, we're going to get some movement, and then it's pretty good. So I'm going to add a little thingy in there about if the navigation is finished, because we've actually lost the ability to move using our arrow keys, and I want to do both. So I'm going to rewrite this part here. Basically, we're going to go if NavigationAgent3d dot is navigation finished, and then we're going to go to this if direction stuff here, right? Oh, whoops. So we need to move that up by holding Alt and pressing up, right? So then what we can do here is go else, and then we can stick our stuff in there. So we're going to go the var get next path. Basically just move up that crap that we had before, right? And now when we run it, so long as we're not navigating, we can actually move around using the arrow keys. So you see, we can move, we can move, we can move, and then we can make it so potentially if we hit one of these buttons on the keyboard while it's moving, it will stop the navigation, but that's up to you basically. So this is just going to navigate the whole way, and then we're going to be able to move it around. So like I said, it's just good for testing, being able to do both. But you'll see if I try and click on the roof here, it's not going to be able to get onto the roof because obviously there's no way up, which is brilliant. So right click, move around, easy peasy, right? That's pretty good. I'm wondering if there's anything else that we should really add in here. I mean, as soon as you add like animations and stuff like that, it's going to be really, really powerful. So I've just imported this scary Huggy Wuggy that we used in our jump scare tutorial. I'm just going to use this as an example of having animations in there, right? So we'll call this one Huggy Wug. I'll chuck the link down in the description, I think. If I don't, just use your own model of some sort, I guess. Although I'll have the game files for this on Patreon for anybody that can't be bothered actually just following this tutorial. Like I usually do. And thank you to my patrons, right? It's a perfect time to say thank you guys for coming to my Patreon, supporting me there. I really, really appreciate it. So whether you subscribe or not, it doesn't matter. I'm just glad that you guys are supporting me. And you can join for free, and there is a lot of stuff that you can get on there for free. If you really want to support me, you come by Unaccessible or DJ Sim. We've got quite a big update coming for DJ Sim. Should be done within the month. And also Halloween's coming up, so check out Let Me Book. We've only got one user review for this game because it didn't have a marketing budget. So if you guys want to try it, leave a review, let me know. It would really help me out, actually. Otherwise, just like the video, subscribe, all that good stuff. Also follow me on Twitch. So I'm just going to Editable Children. I'm going to get that animation player. We're going to go into the player's code. And then we're going to go down to here where we're in the physics project, physics frame, right? And basically what we need to do is we need to check to make sure that the player is moving. If the player is moving, then we make sure it's animating, right? So we go if animation.player.is playing. So this is the line of code that we need, right? But we're actually going to cut that for now. So what we've got to do is we've got to add in a new variable. is moving, bool equals false. And then what we do is moving equals bool. How are we going to do this? We're going to go velocity dot normalized or length. So if it's greater than 0, it should be, yeah. So if we go print is moving, it should be nothing straight away. Yeah, it should be false. And then as we move, true. And then when it stops, it goes back to false. Right, so that's a little bit complicated of a thing there, but it's also a very, very easy way to do it, right? Which is we check the velocity length, which is gets the x, the y, and the z, and it adds them together, right? X plus y plus z. So that's the velocity, right? So what it looks like is this. Velocity to x, blah, 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 blah. So if that equals 0, and we wrap a bool around it, that's going to equal false, right? Jeez, what is that? Oh, the Let Me Book trailer finally loaded up. Okay, Halloween's coming around, so get on to Let Me Book. So if that is anything but 1 or whatever, it should be true, right? Because it's not 0. So that's essentially what we're shorthanding right here, right? So cool, now we know if it's moving. So what we should do is var new is moving. So we need to check to make sure that, well, we need to cross-references it with what it was doing before. So is moving equals new is moving, right? But what we got to do is we need to check to make sure that they're not the same already. So we're only changing the animation when the state changes, right? So what we can do is we go if is moving is not equal to new is moving. We can go is moving equals new is moving, and then in between that we can set our animation. So if is moving, animation player equals that, else, so the new is moving, else we're going to go, what is the other one? It's like a jump scare or something like that. I don't know, just whatever is like standing still animation is. And now we're going to run that. Just run that. Cool. So nothing. And then we move. We get the walking cycle. Move, walking cycle. And obviously it's not rotating yet, but we can fix that. It should move around. And then when it stops, it goes to this weird jump scare animation. And obviously it's not going to start with that either, but we're not going to worry about that right now. We're just going to do this walking. So also what we can do is just change this speed scale. What if we just change it to 5? It might walk a little bit better. A little bit more sus when he stands still. So we could also make him walk slower if we wanted to. So we didn't need to actually increase this. Because what you're going to find is like it's not always just a matter of increasing, you know, the speed that the animation plays, right? Because then this animation plays faster. So we're going to do the rotating now as well. So here we're working out the direction, right, by what's happening here. And then here we're recalculating it. Okay. So we actually can't rotate the entire thing, or it's going to move the position of where our camera target is supposed to go. So we got to think about this. We should probably only be moving the mesh, right? Because it only really matters where the mesh is pointed. Yeah, this solution doesn't work. Cool, so rotation. We only need to do it when it's moving, right? So what this does is it checks back and forth to see if we are actually moving. So we'll just go if is moving, and then what we can do is you can go var target point equals the Huggy Wug's global position, and then it is plus, yeah, plus vector 3. So we're going to get the velocity dot x 0, and then we're going to get the velocity dot z, and then we're going to normalize it, right? Cool. So we're going to figure out which direction doing that, right? Here we go. We'll just get it all on the screen, and then we can go Huggy Wug dot rotate. No, we want to just go look at, I think. Yeah, look at, target point, and then vector 3 dot up, right? Yeah. So then if we run that, what we should get is we've got a rotation. It's off by about 90 degrees, but that's fine. It's a good start. So what we could do here is with that target point, or this look at, right, is first we'll figure out which way this Huggy Wug is actually pointing. Yeah, so see, it's actually pointing in the X direction, which is classic. So we're going to face it back to the direction that it should be, which is negative Z, I think. Okay, so we're just going to push it this way, 180 degrees. And you see, I'm not actually grabbing the Huggy Wug. I'm grabbing the sketch fab model underneath it, right? Like I said, we can't rotate the entire player. Otherwise, we're going to rotate that position where the camera is trying to get to. Cool. And now that we've done that, we can go to our player, and then we can get rid of that crappy little mesh instance. Cool. Now check this out. We've got our own walking Huggy Wug. And actually, I think the speed actually looks kind of good. It should probably be increased a little bit. The speed of the animation, I mean. But really what we should be doing is we should be slowing the speed down of the character to actually match what the animation is. So it should be going down to maybe 4. Do we have a jump? Yeah, we do have a jump. I even realized we had a jump in there on space. So this is pretty cool, right? And now if we were to use the arrow keys as well, because we're basing our direction on the velocity itself, it shouldn't matter what direction we're going. It's always going to be facing the way that we're moving. Cool. So this would be a really good way to create like a stealth game, like I said, like an XCOM-style game. Really anything. I mean, if you were to render this at like a lower resolution, you could even make it look like it was sort of pixel graphics. So what I could do there is if we go to window, go to 640 by 480, and then we'll see what that looks like. It's going to look a little bit janky, I'm sure. We've also got to change this. We've got to change it from canvas layer to a viewport or whatever. Hold on. The scaling. Yeah, so it's here. You go to display, window, and then you go down to stretch mode. You can change that to viewport, and then instead of fractional we can change it to integers, so we'll get like an actual sort of true to life pixelized representation of what we're looking at. Now this is kind of cool. I mean, you can also change the frame rate and things like that to make it look a little bit more pixely, but I really like this. This is really cool. So obviously there's a lot of things that you can do. We've got the real shadows there. We can turn all this stuff into buildings. I mean, we can put enemies in the game, stuff like that. Really whatever we want, but I mean, this is just a very simple walk around, and then we're going to get the orthogonal to show us why we choose orthogonal, and that is that it is dodgy as hell, and we love that. And again, a very special thank you to my patrons, all of my all-in squillionaires and the rest of you free fellows. Thank you very much for supporting this channel. I really appreciate it. Come follow me on Twitch. We're doing game dev every other day of the week, and be good to see you there. Thanks very much. Hit the follow, all of that crap, and I'll see you next time.